Hi, welcome to my video on the combination of triangles, right triangles 30, 60, 90 and 45, 45, 90. Note, do the units on the square root radicals and the unit on the right triangular trig first. That will help you in the manipulation of this video, exercise we're going to do. Number one, find the exact parameter of triangle NTV. NTV is this triangle. Notice we have a perpendicular down right here. So that means that's a right angle on this side. Because if you got a 90, that's 180. And 90 from 180 gives you 90. So 90 and 90 is 180. This angle is 30. So that means that this angle is 60. Because the right triangle, the acute angles are complementary. This angle is 45, it means this one is 45. Because this is a 90, these two angles add up to 90. So it says find the exact parameter of the triangle. Because we have a 12 here, let's start with this triangle. So this is 30, so what I'm going to do is draw this triangle separate so we won't get it mixed up. And let's call this a V. Oh, that's already a V. Let's call it a W. So we can notify or identify what I'm going to do. So that's a 30 and that's a 60. So that's 30, so that's N. And this is 2N. And this is N root 3. So in this triangle, 2N is equal to 12. Divide by 2, N equals 6. So N is 6, so this side is 6. So this side, N is 6. So this side is 6 root 3. So I have a 6 root 3. And we have a 6 right here. So that works that out. Now we got to work on this triangle. So in the triangle, let's work on the triangle NWT. NWT. So this is a 45, 45. So I'm working on this triangle now. So we have a 6. So since two angles are equal, the sides are equal. So that means this is N, and this is N, and this is N root 2. So if that side is N, this side is 6, this side is 6 root 2. So go back, TW is 6, and TN is 6 root 2. And the perimeter of the triangle is, we have to go around, so we got 6 root 2 plus 12 plus 6 root 3 plus 6. And when we add these up, 12 and 6 makes 18. And 6 root 2 and 6 root 3 cannot be combined. So they have to stay, but they're not like radicals. We can't add them. So that's the perimeter. And again, I didn't put in the units, so the perimeter would be whatever the unit is, feet, inches, centimeters, millimeters. That's what this is. Number 2, let's have a look at. Now you can pause your video at any time and work out the problem beforehand and press play to play back to see if you get it right. That's your choice. Triangle PQR is isosceles. PQR is isosceles. Sorry, equilateral. No, I said isosceles again. I make mistakes, so I got to catch myself. Triangle PQR is equilateral. PQR is equilateral. That means that all the angles are 60. So this angle right here is 60. And PR equals PQ equals QR. So all these sides are equal. And pH is 2 root 6. So pH is 2 root 6. And pH is an altitude of triangle PQR. An altitude is a segment drawn from a vertex perpendicular to the opposite side. Altitude is height. So that's a perpendicular, making this a right angle and this a right angle. So PHR, PHQ is 90 degrees. And it also says that triangle QTR is isosceles. QTR is isosceles. So this is an isosceles triangle with a right angle. That means that this is the hypotenuse, so these two legs must be equal. And since those legs are equal, that means this angle is 45 and this angle is 45. Find the exact parameter of QPRT. So I have to get all of these sides. So here we go. How will we do it? Well, I'll do it by, again, drawing separate triangles. So we have a 60 and a 90, and we have, that's a P, and that's R, and that's H. So we got a 2 root 6. That's a 60, 60, 90. That's 150, so this angle is 30. Or if this angle is 90, the two of these adds up to 90, so that's 30. And since this is a 30, 60, 90, this is n, this is 2n, and this side is n root 3. So that means that n root 3 is equal to 2 root 6. So I divide both sides by root 3. Cancels. And so that's a 2. Root 6 divided by root 3 is root 2. So n is 2 root 2. 2n is twice that. So it's 2 root 2. So 2 times 2 root 2 is 4 root 2. So this side is 2 times 2 root 2, which is 4 root 2. So we have PR is 4 root 2. So that means this side is 4 root 2, because this is an equilateral triangle, all sides equal. So that means that means that QR is 4 root 2. But because this is perpendicular here, these two triangles are congruent. And you can see that 60 equals 60 as a pair of angles. This angle equals this one. And this side is common. So these two triangles, PHR and PHQ, are congruent by AAS. And there are other ways. We could have this is a common side, PH, to both triangles. This side equals this side by equilateral triangle. And so we could have an HL, a right triangle with the hypotenuse equal and the legs equal. So many ways to have these triangles congruent. But anyway, if these triangles are congruent, that means that I have QH equals RH, because the triangles are congruent. That means that QR is split into half, so that means that there's QH is equal to 4 root 2 divided by 2, so it's 2 root 2. So that means QH is 2 root 2, and QR and RH is 2 root 2. But did we need to do all that? Well, you could say, well, I have, and now let me draw this triangle. So I did all that work, but did I need it? Well, let's see. We got a right angle. We got these equal. So this is QRT, and I have this right here, QR, is 4 root 2. Because this is an isosceles triangle with 45-degree angles, that means this is n, and this is n root 2. So that means n root 2 equals 4 root 2. That means n is 4, because they cancel out. Or what number times root 2 gives you 4 root 2 is 4. So that means that's 4 and that's 4. So 4 and 4. So the parameter of this quadrilateral is 4 root 2 plus 4 root 2 plus 4 plus 4. 4 root 2, 4 root 2, 4, and 4. And that gives me 8 root 2 plus 8. And again, whatever units we have, it's going to be that unit. Because when perimeter is in centimeters and millimeters or feet or inches or... Okay, let's continue. Number 3. Perimeter of triangle ABC, which is equilateral. So this triangle ABC is equilateral. And its perimeter is 12. So the perimeter of the triangle is 12. So that means the perimeter is equal to 4s, 3s. We got a triangle. 1, 2, 3 sides. The perimeter of an equilateral triangle is 3s. So it means 3s is equal to 12. Divide by 3, and I get s is equal to 4. So that's a 4, that's a 4, and that's a 4. Okay, and because it's equilateral, that means that this angle is 60. And that means this angle up here is 60. That means that this angle right here is 60. So that's a 60. And this angle is 60. Okay, let's see what else we have. AF is perpendicular to BC. So AF is perpendicular to BC. That forms a right angle there and a right angle there. It says that angle EBF is equal to FEB. So it means that this angle right here is equal to this one. And that's given. And we got a right angle. Find the perimeter of ABE. We got to find the perimeter of this triangle right here. So let's go to work. We have a equilateral triangle. That means the sides are 4. This is 60. So if this is 60 and that's 90, that means this angle right here is 30. Because we have that, now I'm going to take that out separate, like this, so you can see it, and we won't get confused. Right angle, 60, and this is 4, and this is 30. So according to this triangle, this is n, this is 2n, and this is n root 3. So 2n is equal to 4. Divide by 2, n equals 2. So if n is 2, that side is 2. N is 2, that side is 2 root 3. So I got AF is 2 root 3. Now, how can we go further? So I got, this is 4, and that's a 2. And this is 2 root 3. So AF is 2 root 3. Keep track of that, this triangle right here. So, why did it give me these angles equal? Because I got a 2 here, and let's see, that's a 4, and I got a 60. That's a 2 root 3. So that means that's a 2, that's a 4 and 4. That's equal. So this triangle, as you can see, is 60, 60, 30, 30, and these sides are equal. So these AFB is congruent to AFC. So that makes these two sides, FB equals FC. So that's a 2, because this triangle and this triangle are congruent by AAS. So since that's a 2, and these two angles are equal, that means this is a 2, because if two angles are equal, the sides opposite those angles are equal. Or this is a 90, so that makes that a 45 and a 45. So if these two are equal, that's an n. So let me draw that out now so I can keep it straight. Here we go. So we got a 45, 45, 90. So I got a 2, 2, so that's an n. This one is n root 2, n root 2, which means n is 2, so that side is 2 root 2. So this side right here is 2 root 2. BE is 2 root 2. So I got a 4. I want the perimeter of triangle ABE. ABE. So I have a 4. I have a 2 root 2. So I got to get the length of AE. Well, let's look at, I'm going to do it separate here. So you can see it. Here we go. So what we have is that AF from here to here is 2 root 3. And EF is 2. So that means that AE is equal to AF minus EF. So AE is equal to AF, which is 2 root 3 minus 2. So this segment right here is 2 root 3 minus 2. Keep that in mind. So the perimeter of the triangle, here we go. So the triangle ABE, the perimeter of that triangle is AB plus BE plus AE. So the perimeter of this triangle is AB plus BE plus AE. So AB is 4. BE is 2 root 2. And AE is 2 root 3 minus 2. And add all that up. 4 minus 2 is 2. 2 root 2 and 2 root 3. Because I can't add these radicals together because they're not alike. Again, a little bit more to this problem. I always like to make some extra problems up to make you think. And again, I used 2 triangles, 45, 45, 90 and 30, 60, 90 and worked it through. Now, the last page. Notice I'm doing, I got 2 triangles, 30 and a 45 with a 90. And I'm reading out that find the exact values. Notice these are sine, cos, and tan of the different angles. So when I use trig, I don't use the n root 2 or n2n n root 3. What I do, this is 60. What I do, instead of going n, I go 1, 2, root 3. Because what I did, if you think about it, I said that was n, that was 2n, and that was n root 3. When I'm doing trig, I let n be 1. So if n is 1, that's 1. N is 1, that's 2. N is 1, that's root 3. I used a 1, 2, root 3 triangle. It's easier to use this triangle when doing sine, cos, and tan. And over here, I use, that's a 45. So this is a 1, and a root 2. Why? Because in a 45 right triangle, this is n root 2. So n is 1 again. So when you let n equal 1, you get this triangle. When you let n equal 1 right here, you get 1, 1, and you get a root 2. 1, 1, n is 1, so it's root 2. So these are the 2 triangles. 30, 60, 90. Across from 30 is 1. Across from 90 is 2. Across from 60 is root 3. In a 45 right triangle, when you're doing trig, I go 1, 1, 2 sides equal with a root 2. I'm going to use those now. Find the exact values. 5. The sine of 60. Here's 60. Sine is, and we got to use SOHCAHTOA now, S-O-H-C-A-H-T-O-A. And that reads, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So sine of 60, sine is opposite over hypotenuse, which is root 3 over 2. Plus the cos of 45. The cos of 45 is 1 over cos of 45. It makes no difference. Cos is adjacent over hypotenuse, so it's 1 over root 2. So we multiply. That gives us 5 over 1. That gives us 5 root 3 over 2. And 1 over root 2 becomes root 2 over 2 when you want to rationalize. So it gives us root 2 over 2. Root 2 times root 2 is 2. And the denominators are the same, so we write it down and we add. So it's 5 root 3 plus root 2. You cannot combine these because they're not like radicals. B, the cos of 45. The cos of 45 is, cos of 45 is 1 over root 2. Cos is adjacent over hypotenuse, 45. Cos, 1 over root 2. The tan of 45. The tan of 45, tan is opposite over adjacent, so it's 1 over 1. So tan is 1 over 1, which is 1. The sine of 30, sine is opposite over hypotenuse. The sine of 30 is opposite over hypotenuse, is a half. So when you simplify that, you get, notice I got 1 over root 2, so I'm going to make that root 2 over 2. Root 2 over root 2, because I have the rationalized denominator, so 1 times root 2 is root 2. Root 2 times root 2 is 2. And 1 times a half is a half. So because I'm dividing, I multiply by the reciprocal of 2 over 1. So they cancel out, and I get root 2. That's the final answer when you simplify. And C, I have a root 6. What's the cos of 30? Cos is adjacent over hypotenuse. The cos of 30 is adjacent over hypotenuse, so it's root 3 over 2. The sine of 45. The sine of 45, sine is opposite over hypotenuse. 45 makes no difference which one. So sine is opposite over hypotenuse, which is 1 over root 2. So I multiply this one, and I get root 18 over 2. And I multiply this one by root 2 over root 2, the rationalized denominator. I'm not allowed to have a radical in the denominator. So 1 times root 2 is root 2, and root 2 times root 2 is 2. But I have to simplify root 18. The root of 18 is the root of 9 times 2. So that's a 3 root 2. So 3 root 2 over 2 minus root 2 over 2. The root of 18 can simplify to 3 root 2. You should always just simplify this because you can't add root 18 and root 2. So we have the same denominator. So we have a 2. So we subtract. We can add on the opposite, add on negative root 2. 3 subtract 1 is 2. These are like radicals, so I can subtract them. So 3 subtract 1 is 2, root 2. The 2's cancel. So this becomes just a root 2. And let's continue. D, cos squared 45 plus 3 cos 60. So the cos squared, that squared is there. So the square is outside. So what's the cos of 45? The cos of 45, cos is adjacent over hypotenuse. So 45 adjacent is 1 over root 2. And the cos of 60, cos is adjacent over hypotenuse. The cos of 60 is cos is adjacent over hypotenuse, 1/2. And I could square this now or simplify it, but if I square this, I should always told to simplify. So that becomes root 2 over 2. I have to simplify the inside of that first. So when I square now, root 2, so root 2 over 2 times root 2 over 2. Root 2 times root 2 is 2. 2 times 2 is 4. Square is gone. And now I can make that 1/2 by reducing it. And that's, I have to multiply, so I get 3 times 1 is 3 over 2. So that's common denominator is 2. 1 plus 3 is 4. And that reduces to a 2. 4 divided by 2 is 2. So notice you work at the cos of 45 first, and then you square it. And here you work out the cos of 60, and you multiply by 2. So you got to do the inside of this bracket first. Simplify this. Then you do. Remember, you're doing PEMDAS. P-E-M-D-A-S. So I did the cos of 45, and then I squared it. And I had to square before I touched this. So I squared it, and then I multiplied after, according to PEMDAS. I did the inside first. I did the exponent next, and then I multiplied, and then I added. So notice the order. And that takes us to the end of the video. And if you like my video, click the like button, click the subscribe button, click the notification bell. There's more videos coming. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel, Math Fully Explained. Thank you for viewing my video. Bye-bye.